Hello everyone, welcome back. In this video, I'm going to explain another very popular sorting algorithm, and the name is quicksort. So just like merge sort, quicksort also follows the divide and conquer approach. That means here the array is split into subarrays, and these subarrays are recursively called to sort the element. So the main principle of quicksort is that it picks an element as pivot and partition the given array around the pick pivot. Now there can be different ways to select the pivot point. We can select the first element as pivot or the last element as pivot. We can also randomly select a pivot element, or we can also take median as pivot. So depending on the selection of the pivot point, the program for quicksort will be different. Now let's see how this divide and conquer principle works in case of quicksort. So for the divide step, the array is divided into subparts taking pivot as the partitioning point. The elements smaller than the pivot are placed to the left of the pivot, and the elements greater than the pivot are placed to the right. For the conquer step, the left and the right subparts are again partitioned by selecting a pivot element for them. This can be achieved by recursively passing the subparts into the algorithm. Now the combined part does not play a significant role in quicksort. The array is already sorted at the end of the conquer step. So we can see from this diagram that in this array we are taking the last element as the pivot point. After that we are just taking all the smaller elements in the left side and the bigger elements at the right hand side. Then again we will partition each of the subarray into some subarrays by taking the pivot point, and it goes on. So now let's see how we can implement this concept using program. So for the program, a pointer is fixed at the pivot element. The pivot element is compared with the elements beginning from the first index. If the element greater than the pivot element is reached, a second pointer is set for the element. Next, the pivot element is compared with the other elements and take like a third pointer. If an element smaller than the pivot element is reached, the smaller element is swapped with the greater element found earlier. Next, the process goes on until the second last element is reached. Finally, the pivot element is swapped with the second pointer. Now, the left and right subparts of this pivot element are taken for further processing, and the subparts are again divided into smaller subparts until each subpart is formed of a single element. At this point, the array is already sorted. So let's just take an example. Here we have an array, and I'm taking the last element as our pivot point. So by the rule, we have to keep all the values, those are less than 2 should be in the left hand side, and all the values greater than 2 should be in the right hand side. So let's see how we do it. So as I explained the steps earlier, a pointer is fixed at the pivot element. Then pivot element is compared with elements beginning from the first index. Now if the element greater than the pivot element is reached, a second pointer is set for the element. Here 8 is greater than 2, therefore here I am setting the second pointer. Now I'm keep comparing all these elements with the pivot point 2. 6 is greater, so keeping as it is. Now I found 1. 1 is smaller than 2, so 1 will be swapped with 8. 8 was the greater we found earliest, therefore we are just swapping the value of 1 and 8. Next our second pointer is 7. Now we are again comparing all these elements with 2, and we found that 0 is less than 2, so we will swap the position of 0 and 7. So after swapping this, again we will continue. Then we find 6. 6 is greater than 2, but now we can see all the other elements are also greater than 2, so we will simply the pivot element with 6. and finally pivot element will be in its intended point. Now at this point we will split this array into two sub-arrays. One will contain with the smaller numbers, the other will contain the greater numbers. So again we will continue this process. We'll subdivide, take this pivot point in all these two sub-arrays and we'll keep splitting. So finally in the end we will get all the elements separately, and all these elements are already in a sorted order. So in the next video I'll show how to implement quicksort using C program. Thank you.